Hello, I thought I would do a review video with you, just as an extra review to see if it might be helpful or not. I'm in my office at school. There's a big window behind me, so I hope you can see me. I know that was scary. And there's no telling who might interrupt us. So we are going to go through page 712. In your book it says Chapter 9 Test, and we're going to use it as a review, just to go over things again. Maybe I'll say something just different enough for you to catch on, or just so that you can hear it one more time. So make sure you have some paper out and something to write with, and graphing calculator is always good. And we're going to go through starting with number 1 all the way through number 15. So hang on to your seat. Alright, I'm back, and we are looking at number 1. James receives a salary of $300 per week plus a commission of 3% of the amount that he sells. Create a table, a graph, and an equation to represent his weekly earnings on sales of $0 to $10,000. Now you should be able to do this, assuming that you're ready for your test. If I were doing this, I would start with a table and equation. So you think to yourself, he receives $300 a week no matter what he sells. So he's obviously going to be adding $300 to his salary. Then you look at the commission of 3% of the amount that he sells. So if he sells X amount, he will earn 3% of that, which is the same as 0.03 times X. Think about that for a second. That makes the equation 300 plus 0.03X, because he gets 3% times the amount that he sells plus a flat rate of $300. Now you need to make a table using that 300 plus 0.03x, ranging from $0 to $10,000. You can do that however you want. The input values don't matter. To simplify it, I did mine. Want to see? I did mine with 0, 2,000, 4,000, 6,000, 8,000, and 10,000. And then you find the Y values. So pause the video and do your table using the equation, come up with your Y values, and you should be able to use that same equation, type it into your calculator to graph, or use the table values to graph. So you have your table, your equation, and you should be able to sketch a graph from that, or type in the equation to your calculator and sketch a graph from your calculator. And then turn the video back on when you want to see what your results should look like. Alright, I have moved locations and changed days, and we're going to try to get through the rest of this Chapter 9 practice test. I'm looking at number 2, and you should be as well. Make sure that you have your book open. Don't just let me read it to you. Number 2 says, while standing at the top of a cliff, Kurt accidentally knocks a stone loose. The table shows the height of the stone in meters after t seconds. And it actually should be after s seconds, because I put an s there, but anyway. Letter A. Create a graph and an equation for the data by using time, t, as the independent variable. Independent variable means that t is your x value and the height is your y value. The easiest way to do this is to type in the time as the L1 list on stat and the height as the L2 list on stat. Then graph it using zoom stat and determine what type of graph you think it is. Is it linear? Is it quadratic? And then choose the regression that's going to give you the best equation that models the data. Alrighty? So I want you to turn it off, turn the video off, type in all your values, find the equation, and when you come back, you can check your equation to see if you got it right. Alright, well hopefully, after typing in your table, you looked at the zoom stat and you saw some odd looking arch. If you have yours as a dot mode, then you may just have a series of dots in that type of shape, and that's fine too. Alright, now what shape does that look like? To me, it looks like part of a parabola, and I realized that on number 2 you hadn't learned how to do that yet, but now that you know how, I think we did that around 9.5 or 9.6, you looked at the shape of the graph families or the function families that you've learned so far. And this looks like a parabola to me. So I'm going to check that first, and I'm going to go Stat, Calculate, Quadratic Regression. Enter, enter, and I'm looking for that R2 value. Remember, if your R2 value is not there, then you go Second, Catalog, and scroll down to Diagnostic On. Enter, enter, and then go back to Stat, Calculate, Quadratic Regression, and you should get an R2 value of 1, which is what I got. If you get an R2 value of 1, then that's as close to exact as you're going to get. Now, the B value, when you hit enter to get your quadratic regression, I'm getting A is negative 4.9, B is negative 1.6 times 10 to the power of negative 11. That's an incredibly small number. In fact, it's so small that it may as well be 0. So in the book, they don't use that value. They write the equation as negative 4.9x squared plus 620. So your answer for A would be h equals negative 4.9t squared plus 620.